Welcome to lesson 5.4, triangle proofs with parallelograms. We're going to go back to our old favorite, some proofs about triangles. But this time we're going to change it up. This time we're going to start integrating the properties of parallelograms to help us out. And I'm going to show you how to do that right now. So pay attention close, let's get into it. Now, I think a good habit would be to, before you even start this lesson, write down the 5 properties of a parallelogram. Okay, they're going to help you out today. So write all 5 of those down. All right, and when you're done writing them down, try to do it by yourself. Pause the video now, come back and see if you got them right. So pause the video now, try to write down the 5 by yourself and check if you got it right. Five properties are. Now, I'm guessing you didn't pause the video. You should have. See if you can do it by yourself, but there they are. And those are the properties that we're going to use to write some triangle proofs. So let's start with the first one, okay? It says ABCD is a parallelogram. So this guy's a parallelogram. You might also say, you could also see this, A, B, C, D. They can just use this symbol. It means the same thing. All right, so I'm going to say this. Before we get started, there are many ways to prove that these two triangles are congruent. All right, and I'm just going to show you one of the ways. But you should know that there is actually more than one way to do this proof. And I'm just going to go through one of them with you, okay? And if you think of a different one, I dare you to try it by yourself. All right, try doing it a different way. I encourage it. So, how about this? So let's go into this. We want to prove that these two triangles are congruent. Well, to start off, if we know that this is a parallelogram, we know the opposite sides are congruent. Okay? And I also know that these two triangles share this side. So what you see here is, well, I actually have side congruence already. So that's one way I can do it. All right? So let's write that out. All right? So we have our statements. And we have our reasons. All right. So our only given here was that A, B, C, D is a parallelogram. Okay. And that's a given. And now based on that, I was able to say, 1, that AB was congruent to CD. All right. And I knew that because opposite sides of a parallelogram, I'll just use the symbol here of parallelogram, are congruent. And I also knew that AD was congruent to BC because, once again, the same thing. Opposite sides of a parallelogram are congruent. All right. Now, once again, we know this. This is our favorite one. BD was congruent to BD. We knew that because of reflexive property. And then finally, we'll end off our proof. Now that we've said all 3 things that are congruent, we'll just say our conclusion, which is triangle ABD is congruent to triangle CBD. And that's because of side. Now, this proof is fine, and you should copy it down. You can pause the video and copy this down, but I'm just going to show you, after you've had this copy, some other ways we could have written it, and our proof would have changed over here, but let me show you some different ways we could have marked this, okay? So this way works just fine. It's totally fine. But like I said in geometry, sometimes things aren't so clear-cut. There's more than one way to do something. Let's try a different kind of proof, okay? What if I did this proof? All right, we're going to once again try to prove the 2 triangles are congruent. Well, I could start off by doing this. Let's mark that A is congruent to C, right? And I know that because opposite angles are congruent. I could use the reflexive property again, and I could also use this property, right? I could also say this, that these 2 angles are congruent. The reason I know that CBD is congruent to ADB is because, well, we know these 2 lines are parallel, so this is our transversal, and these are the alternate interior angles. So now I have angle side congruence, and it could have been done that way. So as I'm saying, I'm just showing you one way to do it. You should be able to do it in many different ways. Okay, there's many different ways to use a parallelogram to do a triangle proof, and every single way is right. All right, let's try another one. What we know is XYZW is a parallelogram, and we want to prove that these 2 triangles, XYM, all right, and ZWM are congruent. So these are the 2 triangles we're working with. Now I'll show you a cool way to do this one. Like I said, there's more than one way to do it, but here's one way we're going to do it. All right, let me erase that now that we see where those triangles are. So let's just start marking some stuff here. Now the first thing you can mark is this. We know that we have vertical angles right here, right? Vertical angles are congruent. That's one good thing to mark. Now check this out. Bing, bom, bingy, bing, bah. See how I mark those? Remember, diagonals bisect each other, so you can write that these two sides are congruent and these two sides are congruent. And look at that, you got side angle, side congruence. So now we just got to write the proof and pay attention closely to how this is done. All right, when you're working with parallelograms, you got to be very careful. First statement, x, y, z, w is a parallelogram. All right, we're going to use the symbol here. The reason we know that is because it's given. Now the next thing we wrote down was that these two angles were congruent. So we got this now. This is too easy. YMX is congruent to angle ZMW, and the reason for that is vertical angles are congruent. Are congruent. Let's keep moving here. Let's keep moving. 3. Now check this out. I know what you want to write. All right, you want to write WM is congruent to MW and ZM is congruent to MX, and you're right there. That's actually going to be our step 4. Okay, we're not there yet. What you have to do is say this: YW and ZX bisect each other. All right. And the reason we know that these two lines, these two diagonals bisect each other is because diagonals of a parallelogram bisect each other. Now I know you're thinking like, why'd you have to state that? But first you have to know that they bisect each other to be able to write that they're congruent. And so remember, if you're using this, that the diagonals bisect each other, first you have to state the property that they bisect each other, because diagonals of a parallelogram bisect each other. Then you could start talking about what's congruent. All right? I know that might be throwing you off, but it's a two-step process. So the next thing I can now write is YM is congruent to MW. And now you could just use this, the segment bisector. A segment bisector divides a line in two congruent parts. Now see, so I had to state that there are bisectors before I could even say this part about bisecting. This would have been the reason you wrote, but you didn't know they bisect each other first. So logically, first we state that y, w, and zx bisect each other, and then we can state they're congruent because they are bisected. It's a two-step process. Okay? Now we're going to do the same thing for zm is congruent to mx. The reason is exactly the same, so I'm just going to use the quotation marks. All right, same reason. And then finally, we can write our conclusion, which is 6 triangle XYM is congruent to triangle ZWM, and that's because of side angle side congruence. All right, and like I said, that's one way to do this proof. I like this way to do the proof. It's pretty easy, but there's different ways to do it, and that's just one of them. Okay, let's do 2 more proofs. Okay, they're getting a little more difficult now. First, we know this. We know we know MNOP is a parallelogram. So this guy right here is a parallelogram, and HG is congruent to VK. Okay, HG is congruent to VK. We're trying to prove that HW is congruent to VW. Now, you should say to yourself right now, this is going to be a CPCTC proof. First, we're going to prove that these two triangles are congruent. And once I know the triangles are congruent, then I can start saying, once I know these two triangles are congruent, I could use CPCTC to prove that HW and VW are congruent. So let's talk about how to do this, okay? Let's talk about how to do this. Let me clear this ink first. So our given is this. We know HG is congruent to VK. All right, that's the first given. 2, once again, we see our vertical angles, so we're going to mark our vertical angles. And we need one more piece of information, and I'll show you how to do it. We're actually going to use alternate interior angles. So if you highlight these two sides, these two sides, they're parallel. We know in a parallelogram these are parallel sides. We also know that this is a transversal right here. It's one of the transversals. Obviously there's another transversal, which would be this guy. But here's one of our transversals. And if that's a transversal and these two lines are parallel, we have alternate interior angles, right? Are congruent. So now we have angle side congruence. We're going to write our proof out, so pay attention real close here on how to do this one, okay? It's pretty straightforward, but it could be, I don't know. It's pretty straightforward. Let's get into it, okay? So let's write our proof. So our statement, and we have our reason. All right. Now I encourage you to try to write the proof before I do, but let's get into it. So step 1, MNOP. It's a parallelogram. See how I keep shortening this more, but that's fair to write. That's cool. MNOP is a parallelogram. That's a given. And we also know that HG is congruent to VK. Okay? And that is also a given. Now the next thing we marked down was that GWH, angle GWH, is congruent to VWK, angle VWK, and that was vertical angles are congruent. Four. We've got two of our things marked. Now we want to get that these angles are congruent. And I know what you want to write. You want to write angle HGW is congruent to VKW because alternate interior angles are congruent. But first you need to establish that these opposite lines are parallel. You can't just go straight into it. So actually what we need to write first, just like before, we're going to do this in 2 steps. Before we could state that the two angles are alternate interior angles and they're congruent, we're going to state that MN is parallel to PO. All right? We're using the fact that these are parallel to prove that these angles are congruent, and that is opposite sides of parallelogram are parallel. Now, because we know these are parallel, remember this is the logical sequence of thinking. Because I know these are parallel, I know angle HGW is congruent to angle VKW, and that was because alternate interior angles are congruent. All right, and first you had to know that these were parallel to prove that the alternate interior angles were congruent. Now that I've got that, I could state the two triangles are congruent. So triangle VKW is congruent to triangle HGW, and that's because of angle side congruence. And let's end off on what we're trying to prove. HW is congruent to VW because of our favorite thing here. 5, 6, 5, 6, 7. Okay. CPCTC. Corresponding parts are congruent, triangles are congruent. Woo! That's a hell of a proof. I'm loving it. Let's do one more proof, though. This is it. Final proof. ABCD is a parallelogram. So this guy is a parallelogram again. All right. See how they use that symbol? It tells us that angle GHA, which is right here, is congruent to FEC, which is right here. All right. And we know that AH is congruent to EC. We want to prove that GH is congruent to HFEF. That is once again going to be a CPCTC proof. Now, if we're using a CPCTC proof, we're going to have to find the two triangles we're going to prove are congruent. And that's this triangle right here and this triangle right here. If I can prove these triangles are congruent, well, hell, then I know I can use CPCTC to prove those congruent. So let's see if we can mark this. All right, let's see if we can mark this. Our first thing we know is, we know that GHA is congruent to FEC. That was given, and we were given that these two sides were congruent. Now the next thing we need to find, all right, and I'll show you what it is. Well, once again, if these two sides are parallel, all right, and here's our transversal, we actually have alternate interior angles here and here. See how this is our transversal and those are our alternate interior angles? And because we have alternate interior angles, we have angle side angle congruence. Now, I want you to try to write this proof out by yourself. All right, try to write it out. I'm actually going to pause the video. You should pause the video. I'm going to write down the answer here, and you're going to come back and check to see if you got it right. All right, I'll see you in a minute. I'm writing down the proof now. Pause the video, see if you could write it by yourself. Let's go. Pause it. Hopefully you paused your video. Now let's just go through it real quick. The first three are our givens, the same givens here. Now remember, we want to show that the givens gave us that we had this angle and this side that were congruent. Now we wanted to actually show that this angle, explain why these two angles are congruent. So first we had to state that the lines are parallel. And we know this because the opposite sides of our parallelogram are parallel. We learned that we had to state that first. Once we know they're parallel, we can use alternate interior angles to prove that they are congruent. So that should be the next step. See, we use two steps here. Since we have all three things explained, we prove the triangles are congruent from ASA, and then we use CPCTC to finish it out. All right, guys, that's it. You're done with your homework for the vacation. Peace out. Have a Merry Christmas. Happy New Year. I'm out.